Triga Jernigan here with exam 4 essay question number 1. Let's go ahead and read it. Explain how solutes and water are reabsorbed in the kidney tubules. Be sure to include the reabsorption of sodium, glucose, water, calcium, potassium, etc. Include in your discussion how the various solutes are reabsorbed, i.e. sodium, glucose, amino acids, and the concept of renal threshold and saturation. Discuss the process of filtration. In your discussion, describe the filtration membrane and the renal corpuscle, there we go, and the pressures involved in filtration. Discuss how blood flow may be regulated to the glomerulus. Describe what GFR is, and then explain the principle of clearance and how it is used to estimate GFR. Okay, perfect. So going into my notes, first is going to be that first point. And so we're going to look first at what a nephron is, because that's our basic structure within the kidney. And so that's where you will see the filtration happen within the body. They're really responsible for filtering blood and your bodily fluids and forming urine from that. So that process begins in the renal corpuscle, and that's made of the glomerulus and Bowman's capsule. So that filtration membrane, that includes 3 layers. There's the fenestrated endothelium, the basement membrane, and the podocyte layer. So when blood enters the glomerulus through the afferent arteriole, the pressures will force water and solutes through the filtration membranes into Bowman's capsule, and that'll form the filtrate. That's where all that filtration is going to happen. That pressure is countered by the capsular hydrostatic pressure and the blood colloid osmotic pressure. So the filtration is really balanced by those 2 pressures, those 2 forces pushing against each other. Once that, excuse me. All right. Once that filtrate starts forming and we have our filtration beginning, it's going to flow into the proximal convoluted tubule, and that's called the PCT, and that's where a lot of our reabsorption is going to happen. So when we look at our reabsorption, it's just things that are being filtered that we can still use, can be reused, recycled inside of our bodies. So sodium in the PCT is very important. Sodium is transported out of the cells and then into the fluid, and that's going to create a gradient that will allow for passive transportation of other solutes like glucose and amino acids through co-transport mechanisms. I'm just going to move my notes a little closer, try to get a better look at stuff. All right. So that brings us to our it's going to bring us to our renal threshold and saturation. And the renal threshold is the plasma concentration when a substance begins to appear in the urine because the transporters are saturated. So if blood glucose levels are exceeding our renal threshold, then glucose is going to be sent into the urine, and that's why you see that in diabetes, because the glucose is exceeding that threshold, and so the transporters just can't transport any more of it around the body, so they start dumping it to be filtered out. The filtrate is then going to enter the loop of Henle, and that's going to be really important in concentrating our urine and making it effective and not wasteful in the body. So the descending limb is permeable to water, but not to solutes. And then the ascending limb is impermeable to water, but it transports our sodium, calcium, potassium, and chlorine out of the filtrate. So we're going to take those ions that we want and move them out of the filtrate so that we can keep using them, meanwhile moving our waste products out. There is there's a mechanism that creates that gradient inside of the body that's called the countercurrent multiplication mechanism, and that allows the kidney to reabsorb the water from the urine, and then that'll concentrate the urine even more. So in the distal convoluted tubule and the collecting duct, the hormones like aldosterone and ADH, or antidiuretic hormone, that regulates the reabsorption of sodium and water. Aldosterone increases sodium reabsorption and potassium secretion, and then ADH will make the collecting ducts more permeable to water, and that'll allow more water to be absorbed. Let's go back into our renal corpuscle and look more at the pressures for this next part of the question. The filtration membrane will allow water and small solutes to pass through it, but it's going to retain the blood cells and the larger proteins. The glomerular hydrostatic pressure drives the process, but then that's opposed by our hydrostatic pressure within the capsule and the blood colloid osmotic pressure. So those two pressures are pushing against each other to make it that we're not just pouring out urine or not giving out enough. And so those two things keep us in balance. The blood flow to our glomerulus is pretty regulated. Those different arteries that run there, those can constrict or dilate, and that'll give our filtration rate, or glomerular filtration rate, our GFR, that'll keep it stable, even if there are fluctuations inside of our body pressure. So if you lose blood, you don't want to piss yourself, so your body is going to make sure that stays normal. So if I'm doing a plasma donation, I'm losing blood, the blood is being taken out of my body, and so my body fixes that. It accounts for that volume loss, and my filtration rate will stay stable so that things can keep going. Just to explain GFR a little bit better, that's the volume of filtrate that's going to be formed per minute by our kidneys, and it's pretty important to show how healthy or how functional our kidneys are. And so we have one way to determine how well that is, and that is the process of clearance. I'm going to draw this out for everyone. Let's see, where's my marker? Because there's a formula that allows us to calculate clearance. So clearance is going to be equal to the urine concentration multiplied by our urine flow rate and that's going to be divided by our plasma concentration. And so this really gives us what clearance is. By determining how concentrated our urine is and how much it's flowing through us, and then knowing how concentrated our plasma is, we can really determine how much kidney activity we have and how healthy they are. All right, I think I covered everything. Let me go back and make sure that I did. Reabsorbed, concept of renal threshold, saturation, process of filtration membrane. Okay, I think I did. Back here for question 2.